Good morning, everybody. All the participants who are present in this hall and all the other participants who are placed at a distance and just but they are well connected with us. So in today's session, I intend to take up the very vital issue of noise pollution, which touches everyone's life. And during this session, I intend to take up the aspects of noise pollution, namely what is noise, then how do we measure it, what are its units, and what are the causes of the noise, how can we eliminate noise from our lives. This will also include, if I get time, I'll show you that how the instrumentation part is there, how we actually measure the noise in the field. So with this basic issues in my mind, we will start today's presentation. And because it touches everyone's life with us, I would also like to get associated that what each of us can do about it to reduce the noise pollution. Every one of us know noise. We have heard of it, and we also know the term sound. So they are quite interrelated, but yet they are slightly different. In the broader terms, we can say that noise is unwanted sound, which you really don't want to hear, or you are forced to hear, or it may be that you want to hear but the level may be very high. So in some it is unwanted. The human beings, we dislike that in one way or another. Now from the basics, sound basically is a form of energy which is emitted by vibration of a body, and then when it reaches the ear it causes some sensation of hearing through the nerves. Now we all know that the signals basically of all the human body, they reach the brain, whether it is a pain in the body, inflammation, any kind of sensation of skin or other parts of the body. So in the same manner, final hearing is actually at the brain level, not at the ear level. The ear will just send the signals. We'll discuss a bit in detail later further. So important thing here is that it is a form of energy. Second thing, it is a form of wave. We have heard of pollution term enough times, and I find that most of us confine focus on one is the water pollution, and it could be relating to wastewater as well. The second is air pollution, and third is land pollution. But this aspect of noise pollution has got a little attention compared to all these forms of the pollution. Yet it has been touching our lives for very long period, and that's why I would like to include it in the form of the environmental pollution. And now it has been identified even by UNESCO, and it is included in the regular form of pollution. Pollution basically, means that any contamination of air, soil, water, and the environment. So basically, these are three main elements: air, soil, and water, which are related to our lives. And environment, a combination of the related conditions through all of them, or independently or in interaction with them, which are surrounding us, where we are living. And even loud noise and sound is also part of pollution. So we can say, as we are discussing, that it is a sound produced by humans and machines that disrupt natural environment and society in general. Now it's a very basic thing, just like we say what is pollution. So as I was saying, the pollution is something which it is a kind of external disturbance in a natural and harmonious living. So human beings, animal species, plant life and other form of life, they exist in nature, and all of them should be living in a harmony. But for certain reasons, human activities or sometimes natural activities, they cause the disturbance in this harmonious living. So that is a kind of environment which is disturbing. When there's a lot of noise, as we are saying that the excessive sound, unwanted sound is noise. So little level of noise may be okay, but when it exceeds certain limits, then we term it as a noise pollution. The sound will become undesirable when it becomes a disturbing factor in the normal activities. So what are the normal activities? The normal activities, like we're working, people are working, we are teaching, we are listening. So, for example, if you are not seated in this room, you would be seated outside, so you would have been hearing lot of other noises. So that becomes unwanted sound. So that is the interference in the normal working, and we need more of the quieter environment for this type of activities like we are doing right now. Then sleeping, we spend a little more 8 to 9 hours of sleep. Every one of us, it's a very significant period, one third of our life, you can say. So if there's excessive noise, you may not be able to sleep. And also during other conversations. So all these human activities which we are doing, if they get disturbed, then we are literally more conscious of the sound pollution. Now, as I was saying that it has been so far underrated environmental problem because we can't see that through our eyes, we can't smell it, we can't taste it. So this is contrary to the other three types of pollution. For example, if you have air pollution, you can immediately, through your sensation of smell, you can detect that. If you have land pollution, if you see some, garbage or some other form of pollution, you can immediately detect that. But this is because, as I said, it is in a form of wave, so that is why it is not, directly visible. But yes, through the hearing, it would become into the visible form. Now, World Health Organization stated for the same reason that noise must be recognized as a major threat to human well-being. Now, if you have sound, so there are two things you can like or dislike, or in some state, you may be not really concerned. For example, I am talking, so you may be liking that he's giving a good talk. Some, maybe I don't know. Some may be feeling disinterested, and if somebody is thought, lost in its own thought of, so he has no actually reaction. अगर कोई किसी अपने और ख्याल में या प्रॉब्लम में उसके दिमाग में है तो वो उसको सुन ही रहा, तो लाइकिंग डिसलाइकिंग का उसमें क्वेश्चन नहीं आता. अब जब हम लाइकिंग की बात करते हैं तो अगर हम लाइक करते हैं तो इट कैन बी टर्म्ड एज ए म्यूजिक, प्लेजेंट साउंड, प्लेजेंट, नॉट एग्जैक्टली म्यूजिक. म्यूजिक हम लोग सोचते हैं कि संगीत, गाना या लिरिक्स और ड्रमिंग वगैरह, बट ए प्लेजेंट साउंड can be termed as music in the literal terms, and sound can be broadly classified in three. It can be speech, it can be music, and it can be noise. So out of these three categories, obviously music is what you like, and noise is what you dislike most, and speech is what you need to do, you may like or dislike, that the question may not be arising. Just elaborating in our daily lives. For example, we have here the group of youngsters and also some middle-aged people like me here. So I've seen that when people travel in a car together, so younger generation would play the music and it louder, and the parents will say, "Oh, volume धीरे करो भाई, volume धीरे करो." तो फिर वो बच्चे कहेंगे, "वो स्पीकर पीछे, आप आगे आके बैठो." Now it is same thing actually. The उसमें noise level same thing is there, but perception is different. Perception is different for different reason. That is because of the liking and disliking. So same kind of sound level can be liked by some people and cannot be liked by some other people. तो वो जो बच्चों के लिए, यंगस्टर्स के लिए म्यूजिक है, वो दूसरे लोगों के लिए नॉइज बन जाता है। तो इसलिए हम इसको बहुत क्लियरली डिस्क्रिप्शन नहीं कर सकते ऑन द बेसिस ऑफ साउंड लेवल्स विच वी आर गोइंग टू डिस्कस. So that's what people want to. So the differentiation between sound and noise will depend upon which factors? First, the habit and interest of the persons. What are your interests? What are your habits? So individual liking and disliking will also matter here. The ambient conditions, the surroundings with you. Now for this kind of environment, anything, if you hear some drilling noise, so that drilling voice, so it will become immediately a noise for us. So the ambient conditions are important. Now if you are sitting in a market area, so you are very well attuned that some kind of noises are going to take place. So mentally you are prepared to receive them. So the ambient conditions are, they also account for your perception as a noise or as a sound. Then impact of the sound. So impact means actually now this becomes noise maybe very softly, बड़ी softly बोल रहे हैं, पर वो अब कुछ बात ऐसी हो रही है कि हमें एक्सटर्नल एनवायरनमेंट से थोड़ा आइसोलेट रहना है, तो ये छोटा सा कुछ वॉल्यूम नहीं है तो ये नॉइज बन जाता है. तो ये एम्बिएंट कंडीशंस. Sound is a sensory perception, and the complex pattern of sound waves is labeled as sound, as noise, music, or speech, which I just discussed with you. And noise has now become very important, and it is now actually termed as a stress factor. So it has started, touching our life in form that it has gone to causing stress in our lives. So we can conclude basically from this discussion that it's a undesirable and unwanted sound, noise. The two issues come. And second is, as I was saying, that it is a sound is a form of energy. So when it is a waste energy, excessive energy, so then we say the noise is a form of waste energy. So it's something, for example, it's of course a crude, correlation. You want to say, heat something in microwave or maybe on gas. So for you have right kind of temperature, to do the kind of cooking. So if you exceed that, it is not going to result into the shorter period of cooking, but it will result into rather getting a bad preparation. So that's how the excessive sound energy which is available, that will have actually the bad impact on our lives. Now let us slightly understand technically that how do sound travel. So we will just see the terminology related to that. Sound travels in form of waves. So it's a kind of vibrations which will travel in the distances. Now for example, I am speaking here and you are listening or you are hearing. What is difference between listening and hearing? Listening you do carefully, hearing you do casually. So I hope all of you are listening.
Both are same.
No, no, it's again, the qualitative matter. If you do with interest, it becomes listening. If you do without interest, it is a hearing. So hearing will have less impact. जैसे हम बहुत लोग संतों की स्पीच पे जाते हैं, तो वहाँ कुछ लोग ऐसे होते हैं घंटा, उनको लगता है हम घंटा स्पेंड करें तो हमारा काम हो गया, और कुछ लोग हो गए उसमें से जो बाद में देखेंगे, सोचेंगे भी उसने ये बात कही थी, तो मैं अपनी लाइफ में इसको कैसे उतार सकता हूँ। तो वो उसने लिसन किया है, तो कुछ लोगों ने हीरिंग किया है। तो जब हम बात कर रहे हैं, इट इज रीचिंग यू बिकॉज आई एम हियर, आई एम द सोर्स एंड यू आर द रिसीवर। तो आपके तक बात पहुंची है किसी मीडियम के थ्रू। द साउंड वेव्स व्हिच हैव बीन प्रोड्यूस्ड, दे हैव ट्रेवल्ड थ्रू एयर एंड देन दे रीच योर ईयर एंड देन दे गॉट द सिग्नल टू द ब्रेन। तो इसका मीनिंग ये है दैट साउंड रिक्वायर्स ए मीडियम बिकॉज it is a wave form, so it requires a medium to travel. So that is why it cannot be transmitted in a vacuum. अगर हम वैक्यूम में कोई भी साउंड जनरेट होगी, it will not be able to travel because we need a medium to carry the vibrations. What really happens is that when the sound waves are generated, they will compress the air. That's a form of energy. Now this is the air medium, जो listening है through air medium. So the compressed air, they will further hit the particles, and through contact it is transmitted at the other side. We'll see a figure and then you will be better clear of that. The second thing is it will travel in all directions. It will not travel in a linear direction. It will travel. So that's why you have seen that if there's a source, it can be heard from all directions. The wavelength, technically, they are the pressure peaks, but before actually I explain, I would show you the figure here. Now just look at this figure. Suppose there is a source on one side. So as I was saying, that these blue dots actually are the air particles, okay, and because they get energy, the energy will make them get compressed, and then they will transfer this energy to the further particles and then come back. So there would be spaces where you will find that there are compressed particles, and they will be immediately followed by the areas which are rarefied, means there are very less number of particles, and the same thing is repeated. So I can have this form of where it is a compression, this is again compression, this is again a compression, and if I just join it, so this becomes this kind of wave, right? That's how actually the sound will travel. That's why we say it travel in waves, and it's more, in physics terms, it is like a sine wave. It's very close to that sine wave. So if you can see here, this is a peak formation, this one and this one. So the distance between the peaks, that is we are labeling as wavelength. So wavelength in terms of a distance, right? Now, if you see one compression area, so it has a top and it has a bottom. And from the center, if I draw a line, from the center, how much it can move above or how much it can go down, that is called amplitude. Right? So we know wavelength and amplitude. Now, there are two kinds of broadly waves. One is, which are more on the longitudinal side, and the other could be, more which also go lateral movement also. So a wave can be combination of them, light waves, sound waves, many type of waves are there. So this is basically what is happening into the medium through which the sound is traveled. Now let me give the definitions. Wavelength, as we saw, is a distance between pressure peaks. The units are very smaller, in nanometers, if you people are aware of that. Amplitude, which I just explained you on the figure, is height of the peak, which represents the pressure intensity and is related to the volume or loudness. So the loudness of sound will be dependent on this amplitude. Then frequency, which of course we didn't depict on the figure. Frequency is number of wavelengths that appear to pass fixed point in 1 second. In physical terms, you can just see that this formation is so quick. It happens many number of times in a second at one particular place. तो वो है, that is called actually the frequency. कि अगर 50 times in a second हो जाती है, 40 times होती है, we'll call it frequency of 40 cycles per second. Means at this particular location, this phenomena will happen 40 times in a second. That's how actually, that's why it is so quick. Because you can see when I am talking, you are listening immediately. There is no gap, time gap. There is no time gap. तो एक पॉपुलर आपने अपने स्कूल टाइम में हमने पढ़ा कि जब वो बादलों में बिजली कड़कती है तो पहले आप वो लाइट देखते हैं फिर थंडर सुनते हैं, बिकॉज द टाइम टू ट्रेवल बाय साउंड वेव्स इज मच लार्जर कंपेयर टू लाइट वेव्स. So you can observe the phenomena, but because it takes time, यहाँ पे distance कम है, so it is happening so fast that for a shorter distance they apparently, because आपकी जो hearing के साथ vision भी है, तो आप visually देख भी रहे हो कि ये बोल रहा है तो मैं साथ ही साथ सुन रहा हूँ. So that is the travel of the sound. Then cycle is a single wavelength, one complete cycle. I think that is called a cycle. So sound is a manifestation vibration which can travel in wave patterns through solids, liquids and gases, all caused by vibration of molecules, follow sign functions and typified by amplitude and wavelength. Now here, just to differentiate that how different type of sound can be there, I am showing you one depiction. There are different curves, you can see. All of these curves actually are of equal amplitude. Amplitude, I just recall back, amplitude is distance of the peak from the center. तो इन सब का amplitude same है, but waveform you can see different. With increasing frequency, as you can see, this is with less frequency, and the frequency will keep on increasing as we are moving to the left. So this is what is going to actually affect the loudness. Similar, this is a kind of source. अपने स्कूल में वो एक्सपेरिमेंट बहुत बार किया, एक फॉर्क से तो करके और वो मेजरमेंट करते हैं, जस्ट टू रिकॉल दैट. So this is if you draw the areas of compressions and rarefactions, that is how it develops. And now this is more, that was the actual, it's made simpler and made more factorized. So this is the amplitude, you can see. This is the wavelength between the two crests. This is called trough, this is called peak. It is actually reversible, doesn't make much difference whether it's peak or trough. The cycle is, you can see the same position which occurs. So if you see this curve, this position and this position are same. So that is called a cycle. This is what we are showing as for a longitudinal wave, and sound waves are longitude. The similar, same figure which I was showing you, but in a magnified form. Sound propagation, could be looked into a kind of roughly as a spring analogy. There are minor springs and they are transmitting to the other one. But that's for more of the technical issues. That's how actually the transmission would take place. So you can, if you are able to focus on one particular location, you will see that same location is a compression and is a rarefication at different moment of time. Just have a look closely. Right? So if I see, say if I spot this one, at this particular moment it is compressed, and another moment it is rarefied. That's how the propagation takes place. So what is really happening? It is through the contact. So that is why no sound propagation will take place in vacuum. And if you draw a sketch at a particular moment, this is what you could see. There are compressions and there are areas of rarefactions. But they will change if you take the picture at another moment. They will immediately change. Now, before we actually address the problem of controlling noise pollution, we need to understand that how it is. So what you have is basically you have a sound source from which the noise or sound is generated. Then you have a receiver, and then you have a transmission path. So when we talk of noise control, we will actually talk of all these three aspects, because we will be addressing three aspects during control also. Now this is the source, and this is the receiver, and that is the path. Speed, as we said, it will depend upon whether it's passing through liquid or gases. Anyone got some idea what is speed in air? Most of you maybe have known. Absolutely right. 332 meters per second in air. What could be speed in water? Do we expect to be less or higher? Less. Okay. What do other people feel? Less.
Less.
Yes. That's psychologically anyone would think in that manner. But coming back to the basics, particles in liquids, they are more closely spaced than air, isn't it? And same thing goes for the solids. They are still more closely packed. That is what we learned in probably class 5, 4 maybe. So where do we then now expect speed of sound to be more? More? Yes. So speed of sound is higher in water, 1500 meter per second, and still more in solids, could be 5000 meter per second. That's too large. 5000 equal to 5 kilometer in a second, right? So thereby, this is important, actually more important for life species underwater. And not
ये नहीं क्लियर हुआ स्टील वाला.
स्टील में जो उसकी है स्पीड इतनी होगी. अगर आप स्टील का एक बार लें और एक साइड पे आप जनरेट करें साउंड और दूसरी पे रिसीव करेंगे, तो अगर आप वो टाइमिंग्स डिफरेंस नोट करेंगे, यू विल फाइंड दैट दिस इज द स्पीड ऑफ ट्रेवल, बिकॉज पार्टिकल्स आर कनेक्टेड, they are interconnected, there is no gap solids में, right? The speed of sound is related to the two the different properties which we just discussed. Like speed of sound in meter per second is equal to the wavelength and the frequency. So it is a multiple of wavelength into frequency. So you can have actually uh, two sounds of same speed, but with a different combination of wavelength and frequency. If one can be less, other will be higher. Speed could be still the same. How do we perceive the sound? The first thing is we need to know that the human ear can detect the sound within a frequency range of 20 to 20,000 hertz. That is the range of perception of human ear. Now, many times we have घरों में होते भी कुछ जो एनिमल्स है उनकी परसेप्शन ज़्यादा है. They can perceive the signals of very low frequency also, for which they use actually to for hunting. Yeah, जो earthquake के times we talk that the dogs have got more perception. So the human ear perception is mostly within this range, and again within this range they have some other properties which I will talk a little later. So means the minimum is 220. The average is 200 to 10,000. That is because of the reason that many of us, because of aging or because of different qualities, the human nature, all human beings are not alike. So most of us, they are more comfortable to detect up to 200 to 10,000. And but many are also, you can perceive within 20 to 20,000. And same person, when in the youth can perceive this, it grows older, the range can keep on reducing. So individual variation takes place. The measurement of sound is done in sound pressure level. When we said it's a form of energy, it causes the compression, rarefactions. So this is the sound pressure level is measured, and the unit which we commonly use is decibel. Of course, there are a number of more units, but this is most common adopted units. And even if now there are more things like LEQs, still it is more well understood and utilized. You can use a sound level meter, which I will show you a little later. The unit is, we measure basically sound pressure level, and the minimum pressure level is 0.00002 pascals. As I was saying, 20, the range of 20, that corresponds to this one. So the pressure which is equal to 0.00002 pascals, which is very small. Those who are attuned to engineering people, civil, mechanical, other who are attuned to crushing tubes or other things, for them, they can say it's too small a pressure. But that's what human ear can perceive. Uh, so this we use actually as a reference level. This is threshold of hearing. This we use as a reference level, and then the units are determined as logarithm of the sound pressure level which we are concerned with to the sound pressure level of the reference sound. The reference sound is the which is barely audible to you, and the barely audible to you is that of 0.002 pascals. So suppose I have a sound which is causing a SPL of 5 pascals, so I will find out log of 5 divided by 0.0002, and that will give you the value. So SPL being measured and reference level. Now this was devised by a well-known scientist, Alexander Graham Bell, who has a number of inventions. But this is too large a unit for our common use, so then we made it decibel. So decibel, is 1 bell will have 10 decibels. Decibel. So this is then written as L equal to this. Another issue here is that, as we say, it is form of energy, and that is the pressure we are saying. If we convert into form of energy in form of watts, then the same value can be stated as 10 to the power minus 12 watt, reference power level, is corresponding to that sound pressure level of 0.00002 pascals. So we can also state this value as log of P square divided by P reference square. Now why we are using P square here? Because the waveforms, they do not have the same value. So we, in the waveform, we always find out the RMS value, root mean square values. So to be more precise technically, then we use the RMS values, and that equation which we are stating, that becomes 10 log P square upon P reference square. So finally it becomes 20 log P upon P reference, right? So P reference is the reference value and P is that of your sound which you are measuring. Now we need to remember that's not a arithmetic scale, so it's a logarithmic scale. Logarithmic scale is 10 times. Now for example, if I double the sound intensity, it will not lead to doubling the decibel value. Simply doubling the sound intensity will not be doubling the decibel value, right? Now if I say for one source the value was 40 and the other source is 80 decibels. The 80 decibel sound is actually 10 to the power 4 times than that value of 40. The increase here is, simple thing is, increase here is 40 to 80. The difference is 40, 80 minus 40 is 40. Divide by 10. 40 divided by 10 is 4. So 10 to the power 4 is the ratio between the two sounds. So to 10 to the power 4, so that becomes 10,000. So if I am saying that sound level from 40 to 50, the increase in 10, but 10 times in the sound pressure level. The increase in 10 units, but it is 10 times the intensity of the sound which is at 40 decibel, right? Then we were saying that two sounds can be traveling at same speed, but you have different combination of frequency and amplitude, right? Now that is what the frequency also plays a role in the perception of sound. So high pitch sound or sounds with high frequencies, even though they may be having same speed of travel and same properties, but they are more annoying. High frequency means high flutter creation, quicker. So obviously that would be more annoying. Many times, now you may ask, we have been here talking of a single source. Single source means one particular source. So I explained it's 40 to 50. But what happens in an environment? Actually, you have sounds from all sources. You can't isolate them. You go to any open area, so all activities are going on, traffic is moving, loudspeaker is going, people are talking, so everybody is contributing. So if you have, the question here is if you add 60 plus 60, there are two sources of sound level 60 decibels. Would they make it 120? Would they make it 120? The answer is no. And it's a big relief, or with great pleasure it's no, which doesn't get doubled up. Otherwise, no, if you can imagine that people are talking 40 decibel, they would have gone multiple of them. So the addition of sound is not a arithmetic. You have to convert it actually back into the logarithmic and then add to find out the value. So 60 decibel plus 60 decibel would finally actually become only 63. Likewise, if you add 60 decibel plus 54 decibels, then the final sound which will be coming out will be of the level 61 decibel. Two sounds of same intensity can increase only by 3 decibels maximum, just by 3 decibels. For that, we can use a graph. This is showing you that this is the difference between two levels. Two levels means, for example, here I'm telling you 60 decibel plus 54 decibel. So difference between these two sounds is 6 decibels. Okay. Corresponding to this 6 decibel, you can read out the addition value. On this side, it is showing you at to highest level. You can see it is from 0, 1, 2, and maximum is 3. So this means maximum increase can be 3 only by addition of two sounds. And this value difference has to be added to the higher one. हम इसको 54 में नहीं ऐड करेंगे क्योंकि 60 की तो ऑलरेडी है, तो जो ऐड करेंगे तो 60 में कुछ ऐड हो रहा है. It's not into the addition to 50. So here you can see corresponding to difference of 6, the addition value here given is 1. So I add 60 plus 1, this becomes 61. Right? You may have more than two sources. तो उसमें फिर आपको ये वाला ग्राफ से काम नहीं चलने वाला. Then we need to make some calculation. So what you need to do is, for example, I want to add 3 levels, 3 sources of 94 decibel, 96, 98 decibel. Then first, this is how I can do by using this equation. Find out 10 to the power 9.4 plus 10 to the power 9.6, 10 to the power 9.8. Add them, find out log, multiply by 10. That will give you the final. So here you can see that again, the highest value in this was 98, and finally it results into increase of 3.1. So I can make one interpretation, जिसको मैं छोड़ के कह रहा हूँ. तो अगर कुछ लोग जैसे क्लास में सो जाते हैं तो उनको मेरी आवाज़ शायद म्यूजिक की तरह लग रही है. Like that. तो यहाँ भी जो एडिशन मैक्सिमम 3 था for 2 sources, it is just little higher than that. It's not really that big a difference. So finally we conclude that the multiplicity of sources does not really lead too much of the difference into the sound. तो पड़ोसी को अगर तंग करना है तो एक ही ड्रम बजा लो, दो ड्रम बजा के भी कोई बहुत ज़्यादा फायदा नहीं होने वाला. Another issue which we need to understand, which will be useful actually when we are talking of sound pollution control, is how the sound level varies with the distance. अब जैसे हम बात करते हैं कि यहाँ एक सोर्स है जहाँ पर जनरेट हो रहा है और परसीव है at a different distance, maybe 10 meters, 20 meters. So at 10 meter the sound level measure will be different, 20 meter sound level measure it will be different, and gradually it will fade away. right? Because sound is traveling in all directions, right? And when the distances are increasing, then the intensity will go down because area is increasing. And we know in simple terms, pressure is force per unit area. तो अगर एरिया इंक्रीज होगा तो प्रेशर लेवल डिक्रीज होता जाएगा. So with the change in distance, the pressure will. So that is why it follows inverse square relationship. Inverse square relationship means the sound level degenerate or reduces with the square of the distance. तो अगर distance 2 times है तो reduction will be 2 square 4 times. This is an example. I show you a source here, and then place A is 1 meter, place B is 2 meter, place C is 4 meter. And if at 1 meter the intensity is say 160 decibel, at 2 meter 2 square 4 divided by 4, 160 by 4 it becomes 40. At 4 meter 4 square 60, तो 160 बटा 16 10. So that means it reduces drastically with the distance. Just from 1 meter where it was 160, at 4 meter it has gone only 10 decibel, which is very, very minimal. Or even 3 meter 17.8, or even 2 meter it is just 40 decibel. So thereby this aspect also we have to remember when actually we are measuring the sound. अगर मैं कहता हूँ कि कोई पटाखे की आवाज़ है, तो पटाखे की आवाज़ कहाँ से, अगर आप उसके पास से आपने मापी तो उसके 2 मीटर से मापी, 6 मीटर से मापी. तो वी नीड टू बी वेरी स्पेसिफिक व्हेन वी आर टॉकिंग ऑफ द लेवल्स एंड डिस्टेंसेस. तो इसको मेजरमेंट करने के लिए एक इंस्ट्रूमेंट होता है साउंड लेवल मीटर. और क्योंकि हमने पहले बताया कि कुछ जो फ्रीक्वेंसीज होती हैं हाई पिच, उनका परसेप्शन डिफरेंस है, तो दैट इज व्हाई वी यूज फिल्टर्स, ताकि जो उनकी, बिकॉज फाइनली व्हाट वी वांट टू नो इज द लाउडनेस व्हिच ह्यूमन ईयर परसीव्स. तो जो हाई पिच साउंड है वो फ्रीक्वेंसी रेंज में फिल्टर अलग यूज करते हैं, और जो लो फ्रीक्वेंसी साउंड है उसमें अलग फिल्टर यूज करते हैं. So accordingly then we describe as DVA or DVC. So before I continue, I will just like to show you this instrument. Maybe you can have a look. आपको थोड़ा सा, this is called sound level meter, and we have mic here. This can be detached. This is mic here, and this will give you directly the reading. I can just switch it on, and right now it is say showing you some value 40, 55. So you can see it's decreasing, changing very, very quickly, because when I speak तो उस टाइम ज़्यादा होगी, जब बिल्कुल क्वाइट है तो कम होगी. तो ambient air noise will also be there. There are, it has got buttons for different ranges because of suitability. You can't read, but I can read it. Maybe I'll just tell you what actually it is. So one range is, for example, 40 to 90 decibel, 40 to 90, and this is for 80 to 130. So I switched on this range because my sound level are within this. Now you can see it is 65 because I am too close to that. So it is perceiving. Goes down to 45, right? Then there are kind of auto reset buttons, because I said that the sound levels keep on changing. You have just seen that. So obviously uh, you need to measure very frequently, right? So auto reset button is pressed, it will keep on recording number of values within a second and then give you the reading of average value when you do the measure. This is frequency weighting A, and this is frequency weighting button C. So we are using frequency weighting button A. Then slow and fast. That is again the response of the instrument to the sound level. There is one button which is for impulse. This button is for impulse. You can't read that, but this button is for measuring the impact sounds, which, for example, a hammer, jackhammer, which happens, the sounds which are for very, very short duration. Likewise, a jet engine takeoff, it produces the highest pitch of very short time. For them we use impulse, and this is quite commonly used in measuring sounds in industry conditions, जहाँ पे बहुत सारी प्रोसेस है जिसमें हैमरिंग इन्वॉल्व है, तो lifting है, falling है, many such activities are involved. So there we can use the button impulse. Now you can see that the instrument is quite precise, and but you need to know that for a specific condition, like if I want to measure for a traffic noise, so this instrument is then positioned on a stand at 1.2 meter height and then at a specific distance from the roadside. Actually, you can detach this speaker, microphone, and then we have a connecting cables. So I can have the main instrument here, and through the connecting cable, I can place the speaker up to another 10 meter, 20 meter distance without loss of signal. Because when you are measuring it, you will not like yourself to be subjected to noise condition. So you can put the speaker here, there at this near the source, and then you can keep the measurement being there. So some accessories, like tripod stand, just like a camera tripod stand, and the extension cable, that's all you require. So this is termed as a sound level meter and also noise level. Very useful in measuring the noise.
Price कैसे है?
This will range, right from costing something like 50,000, and if you want to buy very, very precise such kind of equipment, up to 2-3 lakh rupees. But an instrument of costing you 60-70,000 can do a good measurement.
India में supplier कौन?
In India, there are a number of suppliers. And whenever you are going to buy, you have to be apart from knowing the technical specification, precision, etc. You should also keep a record that up to what temperature ranges they are useful, because many of the equipment people buy from the foreign makes, and they work well up to certain temperature conditions, particularly up to 40 degrees centigrade, because they are from cold countries. So you need to know the temperature range also. In our country conditions, it should be minimum around up to 60 degrees. Because if you want to know some industrial locations, industrial conditions, they not only have high noise level but also have high heat levels at some places.
And what are the filters exactly and how they work?
Filters, as I was telling you, that the perception of different frequency range is different by human ear. So in accordance, because as I said, the low frequency sounds, they will have lesser impact than a high pitch sound. तो उनको accommodate करने के लिए in terms of loudness they are using the filters.
And what's the material and how these filters exactly filter out a particular frequency?
See, as I saying that ये जो हमारी pitching का condition है, this one, the frequencies, ये, so different sounds of these belonging, ये वाली साउंड और ये वाली साउंड का जो लाउडनेस है परसेप्शन वो डिफरेंट है, जबकि स्पीड दोनों की सेम होगी, प्रेशर सेम हो सकता, तो उसको डिफरेंशिएट करने के लिए इट इज एक्चुअली मोर सुटेड, द फिल्टर इज मोर सुटेड टू परसीव व्हाट इज द इफेक्ट ऑन ह्यूमन ईयर, नॉट सिंपली इन टर्म्स ऑफ द फिजिकल वैल्यूज ऑफ द प्रेशर लेवल. तो वो जो रेंज है विच इज समवेयर लाइक 1000 to 5000 वाली रेंज है, उसका इफेक्ट जो है ह्यूमन बींग्स के ऊपर ज़्यादा होता है. तो इसलिए उसको थोड़ा जो मेजर करता है उसको थोड़ा मल्टीप्लाई करके ये रिकॉर्ड करता है, और जो लोअर फ्रीक्वेंसी है उसको थोड़ा ये लेस करके रिकॉर्ड. in terms of the, that is use of the filters. Because finally we are interested that how it is affecting human beings. It's not simply measuring on a instrument basis. Okay. Now we just need to know that what are the normal level of tolerances, and so different sources will generate different levels, like a soft whisper 20 to 30. Normal conversation, you must have seen, this was giving you somewhere near 50, 54. So that is 50 to 60 decibels. Alarm clock 80 decibels. Stereo headphones which you use can give you 100 decibels. And a gunshot or jet plane 140 decibels. A rocket launching will create a 180 decibels. Within our home, where we spend a lot of time, or within the workplace, window AC 55 to 60 decibels, vacuum cleaner 85, mixer blender in kitchen. These are average value, they can vary. It can be 85, it can be 95, it's average value. Unmuffled motorcycle, youngster like bullet, etc., that will cause you 110 decibels compared to the Suzuki or Honda. And a farm tractor will cause you noise of 100 decibels. Behaviorally, if you know what is significance of this, behaviorally 40 to 50 decibel range is considered as a quiet. So that is what you are seeing 45 value when I was not speaking. So that is a quiet condition. 50 to 60 normal conversation, 60 to 70 is loud, and if two people want to converse with each other, they will have to raise the voice levels. Means if this level of sound would have been here in this room, I would have to speak a bit louder so that I would be audible till the end. 70 to 80 if the value goes, people find that they can't hear. जैसे रेलवे स्टेशन पे आप चले जाते हो तो या बस स्टैंड पे, so many times you can't hear it. So that is the value. So it is intolerable for phone use. Now what is the significance of these? Starting from bottom, 80 value is annoying to us. People are comfortable up to around 70, but 70%. 80 becomes annoying. And a truck sound which can be of 90 decibels, it can cause damage if you are exposed to this for 8 hours a day. A sound of 105 decibels can cause damage even if you are exposed for 1 hour in a day. So likewise, you can read that as the sound level increases, smaller duration is good enough to cause damage. So for a 90 decibel sound where we needed, which could have been sustainable up to 8 hours, a gunshot is not even sustainable for a smaller period. A car horn can be just you can sustain just for a 7.5 minute window. No, you will be exposed to that, but now beyond this it has started damaging you, giving you damage. So the tolerance limit becomes smaller as the value of noise becomes higher. The sources of noise pollution are very well known to us. I'll just quickly go through. The major is the traffic noise, aircraft noise, then noise from construction works, industries, horns, explosions, and then miscellaneous like fireworks, religious congregations. All these kind of activities would contribute to the ambient noise. So what we can say is community noise. We all relish it, but finally we also pay for it. And in our country, this is too common. You don't take permission, whether it is a political rally, whether it is a religious congregation. Everybody wants to just want or force other people to listen to what you want to do about it. And within inside environment, in a house, many activities like continuous usage of phone, loud playing of TV, music system, appliances which we use, repair works, they can also contribute to the noise. Traffic accounts for 70% of total noise by the transportation systems, and 20% is about from the aircrafts and 10% is from the railways. A truck which is a speed of 90 km per hour makes as much noise as of equal to 28 cars. So the commercial vehicles, they are more damaging. Then if vehicles are moving at high speed, they will also have high noise. For example, car at 20 km per hour will emit 55 decibel, and this will increase up to 75 decibels if the speed goes up to 80 km. So the speed, number of traffic, and type of vehicle, they all are from the traffic or transportation systems. It is estimate of world level that 3% of the population is subjected to high noise level because they may be living in proximity or they are into that stream, spending more time into that stream. Impact are, we explain this, I will straight away see that what in simple terms it will make you more irritable. That's the adverse effect. There are a number of effects, physiological, psychological, and hearing losses. It can cause number of generally we find that increase in population, so more populated area, they are subjected to rather high noise level because of the high increased level of activity. To understand that how it really affects, we have somewhere near 25,000 hair cells in our ear which will create wave in our ear when you receive the signals, and they will be responding to different level of frequencies. Frequency range बहुत ज़्यादा है ना, 22 hertz to 20,000. So number of, that's why God also has given you more number of hair cells so that you can respond to different levels without. So it's acting as music now. Right. So hair cell will give signal to brain, and they are very extremely delicate. So if they are subjected to high pressures, they will get damaged. तो 25,000 में से कुछ को डैमेज हो सकता है, कुछ परमानेंटली डैमेज होंगे, which finally you will find that they are resulting into different type of adverse effects. First thing is ability to hear high frequency sound can be affected. It can lead to irreversible hearing loss, permanent damage if you are exposed for very longer period to this. It can lead to increase in blood pressure from 5 to 10 mm of mercury scale if you are exposed for 8 hours of even 7 decibel of this level. Hearing loss will begin when you are exposed for 80 to 90 decibel for 8 hours a day. dBA means actually decibel level using filter A. Here. 140 decibel is very painful. Even 130 decibel sound is painful. You will immediately get pain in ear or even in the brain. And if you are exposed to 180 decibel, which was that of a rocket launching, a person close to that can die. So much is the pressure caused because all this pressure goes to the brain, and the brain cannot sustain that pressure. Most of the vehicles give you 80 decibel level. Broadly, we can classify them in two categories, like community noise or environmental noise, which is present in ambient air where you are actually going around the places. So, and then occupational noise, which the place of your work or even of your home, both are included into that. Community noise is congregation of all these sources, and a noise within building is with your activities. It could be industrial activity in some cases. Then you have a plumbing noise, boiler, generator, air conditioner, fans, and many of the activities. Occupational noise. within the factories. Occupational noise level of 85 decibels, because many people are actually they work into the factories or industrial conditions and they are subjected to continuous noise. So it is found that a noise of 85 decibels for 8 hours in a day, that should be limited. If it exceeds this level 85, then it will result into permanent loss of hearing. The World Health Organization recommends that unprotected exposure to sound level like greater than 100 decibels should be limited to 4 hours, and similarly it is different for adult and children. And I will say that the same noise can adversely affect children in a different manner, aged people in a different manner, and youth and middle aged in different. So it should never exceed 140 decibels in adults and 120 decibels in children. And greater than 165 decibels even for a few milliseconds again can cause acute cochlear damages. We can classify these adverse effects in auditory. Non-auditory means reaching to your hearing. Non-auditory, not hearing but other performances of your body level. Physiological and psychological. Physiological and psychological. Hearing impairment, आपको hearing कम हो जाएगा. Decrease in efficiency, performance, your work efficiency, that can decrease. Lack of concentration, people are not able to concentrate. That's very common, lack of concentration because of more usage of the phones, particularly mobile phones, because you are actually persistently exposed to the hearing for whether it may be even low level. People can tend to have aggressive behavior if they are subjected to noise above 80 decibels, mental illness, memory loss, sleep interference, and even speech interference. It may even cause heart attack. Prolonged noise exposures. Uh, Actually, as we say that it will change the blood pressure levels. So it will cause the constriction of blood cells, which can finally lead to increase in BP and then lead to the heart cells. It will may not happen to people who are sturdy, young enough, but when those who are delicate or those who are patient, it can affect easily to them. Lead to digestive problems, lead to pupil dilation, and even for it has been found that if they are exposed, pregnant ladies are exposed for longer duration, even it can result to abortion. Not only human beings, but it affects crops, animals, and even the buildings. I'll just skip this. Anxiety, stress, nervousness, headache, nausea, neurosis, insomnia. Insomnia is different from actually sleep tenses. Insomnia becomes that if you have been exposed to this for longer period, you are not even able to sleep even when you get the quiet conditions. That's called insomnia. Dizziness, fatigue, changes in mood quite frequent. Likewise, many of the things can happen. I'll just list them once again. Hearing impairment is very important, and as we're saying that less than 70 decibels is very safe, but more than 85. So people like truck driver, for example, who are driving the truck for more than 8 hours, they are sure to get the hearing impairment. तो पंजाबी आपने किसी ने देखा भी होगा कि they speak loudly. They speak loudly. Truck drivers speak loudly. It's not because they are habitual, because now they have started listening a little louder. So that is why they speak loudly when they sit even on dhabas to order for roti and so. You may have feeling of fullness in the air. Fullness in the air means आपको लगता है भी कान में ना कुछ है भरा हुआ है, तो वो एक कॉन्टिन्यूस फीलिंग जो है दैट बिकम्स वेरी वेरी डिस्टर्बिंग. साउंड्स में सी मफल्ड, जो एक्चुअल है वो उससे डिफरेंट आपको सुनाई देगा. दैट कैन आल्सो हैपन. You cannot hear high frequency sounds. The range of detection of frequency will reduce. Ringing in ears can happen. Some people explain that ringing in ear, that can be not simply because of excessive noise, but it can also be due to some other medical cause. We know all that just like human beings, the vegetation is also sensitive. They also have life, so they also can be got affected. And the researches have shown that the जो क्रॉप्स आप ग्रो करते हो कूल और पीसफुल एनवायरनमेंट में, यू नो दे ट्राइड विद द सेम थिंग. सभी कुछ सेम है आपके एटमॉस्फेरिक कंडीशन. They found the yield is more in distance villages. Even if you see, जो हाईवे के साथ में फील्ड होते हैं और जो अंदर डीपर होते हैं,
वो जो म्यूजिक चला के देती होती है उसमें और भी ज्यादा होती है. ये भी एक्सपेरिमेंट है.
yes, that's
म्यूजिक चला के गायत्री मंत्र
very right, very right. तो ऐसे एक्सपेरिमेंट्स एक्चुअली इन्होंने किए हैं कुछ ऐसी राइटी से. दे डिड द एक्सपेरिमेंटेशन ऑन जेल इनमेट्स. So they found that those who were exposed to this the kind of music, तो उनका जो behavior था, they found that there was improvement in their behavior in terms of less aggressiveness, those kind of things. So noise pollution can even affect crops, but on animals and birds it is very very significant, particularly on underwater animals, mammals. क्योंकि वो जो मैनी टाइम ऑफ फिश लाइक व्हेल और दूसरी फिश हैं, तो उनके जो लिविंग है, उनकी मैनी ऑफ द एक्टिविटीज कम्युनिकेशन दे आर बेस्ड ऑन साउंड्स. तो वो साउंड्स अगर इंटरप्शन हो जाती है तो देयर नॉर्मल एक्टिविटी लेवल एंड रिप्रोडक्शन आल्सो गेट सफर. दे आल्सो फाउंड कि एक बर्ड है रोबिन, यूरोपियन रोबिन. रोबिन बर्ड हमारे भी यहाँ होता है. तो वो दिन में सिंग करता है नॉर्मली. दे फाउंड कि वो रात को सिंग करने लग गया. पहले तो दिन में खाली करता था, अब वो रात में भी करने लग गया. तो उसके ऊपर स्टडीज की. तो इट वाज ट्रेस्ड बैक कि वो जो सिंगिंग करता है वो प्रेफर करता है इन विस्पर और जो क्वाइट कंडीशन है. और दिन में वहाँ पर नॉइज लेवल इतना बढ़ गया कि उसको अपने सिंगिंग करने का वो चार्म खत्म हो गया, तो वो रात में वो करने लग गया. तो दीज काइंड ऑफ बिहेवियर चेंजेस टेक प्लेस. जू एनिमल्स के ऊपर रिसर्च स्टडीज हुई, तो दे फाउंड एनिमल जूस दे बिकम लिथार्जिक और उनकी हेल्थ भी डिटेरियोरेट होती है. So that is why if you will find that they always say they don't make noise when we are going in the zoos or even in wildlife sanctuaries. That was what I was telling you about European robins. Effect on structures. We all know that noise causes vibrations. The vibrations can itself be disturbing in the buildings. They can damage glass windows. It is a well established effect. कि जो एयरपोर्ट्स के नज़दीक होते हैं वहाँ पे वाइब्रेशन ज़्यादा होती है, या मिलिट्री सेंटर जो है एयर फ्लाइंग के, और वहाँ पे इस तरह से इंसिडेंसेस लाइक प्लास्टर क्रैकिंग, डैमेज टू ग्लास विंडोज एंड इवन बिल्डिंग फाउंडेशंस. बिल्डिंग फाउंडेशन कैसे डैमेज होती हैं? क्योंकि जब वाइब्रेशंस होती हैं बिल्डिंग में, तो वाइब्रेशन होने से वो सॉइल को वाइब्रेशन से कंपैक्शन हो जाता है. सो दैट कैन लीड टू द सेटलमेंट आल्सो. So that the building damage, even not only in superstructure, in bottom, the foundation can also take place. And these are very, very known facts. So how we then overcome this problem? 3 stages I told you in the beginning. You need to concentrate on generation. जहाँ noise generate हो रहा है या तो उसको reduce कर दो. दूसरा जहाँ से वो travel कर रहा है वो distance बढ़ा दो, because it is varies स्क्वायर ऑफ द डिस्टेंस. तो अगर हम अपने आप को उससे थोड़ा डिस्टेंस कर लेंगे तो आपको इफेक्ट कम होगा. थर्ड है कुछ नहीं हो रहा, ये सब कंट्रोल में नहीं है, तो आप जो रिसीव कर रहे हैं वहाँ पे प्रोटेक्शन कर रहे हैं। अब उसके लिए हम क्या क्या कर सकते हैं, skip that. Basic things like good tuning of automobiles and vehicles so that they generate less sound. Speed control करने से, क्योंकि हमने देखा कि स्पीड ज़्यादा से नॉइस लेवल ज़्यादा है। इसी तरह से ऑटोमोबाइल या जहाँ भी वर्कशॉप इंडस्ट्री है, तो जो मशीनरी है उसको इफ़ यू डू प्रॉपर लुब्रिकेशन तो दैट विल क्रिएट लेस नॉइस। हम अपने घर में देखें, अगर एसी की सर्विसिंग नहीं करवाते, फैन की नहीं करवाते, मिक्सर की नहीं करवाते टाइमली, क्योंकि उसमें इंसुलेशन लगी होती हैं, कुछ इंसुलेशन बेसिस होते हैं, कुछ आपके मूविंग पार्ट्स हैं जिसे हम गरारी और गियर्स होते हैं, इफ़ दे आर नॉट लुब्रिकेटेड दे विल क्रिएट मोर नॉइस. So there are simple things which you can do at home. So regular servicing of desert coolers, ACs, fans, etc. will help you reduce that. Keep residential area away from airports. तो जो बिल्डर है वो तो एडवर्टाइजमेंट आपको देते हैं कि दिल्ली में है, चंडीगढ़ में है, ओनली 5 किलोमीटर फ्रॉम एयरपोर्ट, वो आपको उल्टा गाइड करते हैं, ओनली 5 किलोमीटर,
2 किलोमीटर
2 किलोमीटर कह देंगे वो पेरिफेरी से नोट करके. So that is dangerous actually. You are not going to airport every day, but you are living every day. तो साल में आपने अगर 2 दिन एयरपोर्ट जाना है, 3, तो ideally the houses should be located away from railway stations, airports, factories, industries. So new development fortunately in cities like Chandigarh which are planned, or even Bangalore where the planning is being done now, the industrial areas are kept outside the residential area. So even if you see in Chandigarh, the industrial area is away, residential from there. And then there is also vegetation cover given. The vegetation cover will absorb. So it's always good to plant a tree. That's why on the highways, in addition that the tree plantation gives you pure air, it also absorbs the noises. You can do provide sound barriers in Western countries. It is quite common. It is done, kind of planks are being placed over there, which will actually either reflect it or absorb it. But for another technique is absorption. Like in this hall, you can see we have put the sound absorbing materials on the walls, on the ceilings. So no external sound is coming here. You also see it is a double door entry. So now we have got double, in the construction we have got डबल ग्लेज पैनल्स. जैसे आप अगर उसमें ट्रैवल किया आपने एयरक्राफ्ट में या रेलवेज में, तो हमने देखा डबल ग्लास होता है. तो डबल ग्लास होने से क्या है, जो बीच की स्पेस है वो या तो एयर है या वैक्यूम अगर है, तो sound will not be able to cross that barrier easily, बहुत कम होगा. So now in construction also the panels are coming, that you have got panels with the double glasses. So you must have seen that the glass construction is becoming quite popular. So if you are in cities like Gurgaon where very heavy noises are there, you have no option because your workplace is very close to the roadside. And to give more property value, people want to be on roadside. So the only solution would be that you use these kind of the insulations so that the level of sound which comes is reduced. Then government has got, there are of course acts, there is Noise Environmental Pollution Control Act, Ministry of Environment and Forest, they put the act in 2000, they have been doing amendments, and the recent amendment was done in 2012. Laws exist, we know, particularly in our country, but less followed in such cases. So you have banned of usage of loudspeakers 10 p.m. to 6 a.m. Unfortunately, in many cities it's not followed, particularly even by religious congregation. So subah, they want everybody to hear God's voice, less realizing that God's voice is within you, not outside. So those kind of problems, which are social problems. So me and you can probably do one thing. We can make more plantations because it's in addition to giving you good air, it gives you sound absorption. तो आप इतना अगर करें अपने हाउसेस के बाहर प्लांटेशन करेंगे तो आपका नॉइस लेवल भी कम होगा. एंड एक्सपोज रिड्यूस योर exposure to the noise. That's the best thing. But if you can't do that, use earmuffs. Earmuffs special protection आते हैं, तो you can put inside so you can your ear will not receive the signals. और अगर कुछ भी नहीं आप करते, तो simply use cotton. We all are aware of that. So that's the best thing. So thank you very much, and this is what the child want to say. Say no to the noise. Thank you very much. If you have any question,